Hello, I would like to talk to you about my semester project in developing an autonomous robot as part of the ENPM809T course in the Engineering Robotics program in the University of Maryland College Park. In this video, I'll be talking about the theme the project is based on and the mission the project is trying to accomplish, the hardware and software components used to build this robot, the various functionalities implemented on the robot through different homework assignments, finally leading to a grand challenge which required the robot to execute a set of tasks by picking up different items and delivering them to a destination spot. So follow along as I take you through my journey across this semester, which was filled with a lot of fun but had its challenges, which finally culminates in developing an autonomous vehicle. Autonomous mobile robots have a wide range of applications, ranging from delivery operations in warehouses to delivering products and goods to customers' homes, and also in different industries and factories. The healthcare space is one where the increased presence of autonomous mobile robots would be appropriate. And in highlight of the current pandemic, this would pose significant advantages, wherein the frontline medical workers and staff's exposure to the virus can be reduced if a robot is able to perform certain functions. So therefore, this semester's project, in this semester's project, we are looking to make the robot pick up three vaccines. So the three major companies which are manufacturing the vaccines are Moderna, Pfizer, and J&J. So as part of this project, we would be having three items with different colors, which are reference to the different vaccines. And the job of this robot is to pick up these vaccines based on a specific request, which would be in the form of an email or a QR code in this case. So based on the QR code, the robot needs to identify which color vaccine. So the each vaccine is highlighted by color, and it needs to pick up the appropriate vaccine, pass over through a cluttered environment wherein there are different localization signs like arrows or QR codes, and reach the destination point. And the final goal is to deliver all these three items to the final destination spot. And once it reaches the destination spot, the robot needs to perform a facial detection of the vaccine administrator and only then place the vaccine in the other components include 4-brush DC motors, which has encoders connected to it, forming the motor encoder assembly, a battery pack, and the motor encoder assembly is wired through the H bridge, and the H bridge is connected to the Raspberry Pi through the GPIO pins. The next component is the ultrasonic distance sensor, which is capable of transmitting high frequency pulses of sound via the transducers. And this component is connected to the GPIO pins 16 and 18 of the Raspberry Pi through a voltage divider circuit. It also consists of the IMU Fusion 9 degree of freedom sensor along with the Arduino. The other circuit connection is the integration of the Arduino Nano along with the IMU sensor. So this helps track the orientation of the robot, based on which we'd be able to perform different localization functions. The final component is the gripper, which is powered by a servo motor. The servo motor emits the PWM signals, based on which the duty cycle of the gripper can be obtained, and it is important not to exceed the duty cycle of the servo motor. So this is a program which detects an arrow in a video frame using the Pi camera video feed. So the HSV color masking takes place to detect the color of the arrow, and
the corners are extracted from the respective contours, and based on the number of points on the x and y axis of the image, the direction of the arrow is predicted. So this program uses the distance sensor to calculate the distance of the robot from the object, and so that this is where the trigger pulse and the echo pulse are set, and based on that the distance is computed. So in this program I move forward by a particular distance, I move forward for a particular time frame and extract the distance from the object from it in all directions: forward, reverse, left and right. So my robot performed poorly in the grand challenge. It got triggered by the email and it was able to detect the QR code and orient itself to the right vaccine, but it did not move forward to pick up the vaccine. It was also able to localize itself based on the QR code and the arrow, but it went out of the arena and had to lift the robot manually, thus ending my run as part of the grand challenge. I did a lot of test runs to ensure that most of the tasks of the grand challenge are complete. And some of the issues which I faced was regarding the IMU values, wherein there was a delay in getting the IMU values, and the robot would continuously pivot itself until the values are generated. So to solve this issue, I implemented a multi-threaded operation wherein I am running a thread to get the IMU values. This, in a way, solved this problem. Though there was an initial delay in getting the IMU values, but most of the times it was correct. And the other issue was related to the straight lines using the encoders. So I used the IMU values in this case as well, wherein I continuously keep checking the orientation, and if the robot is oriented towards the left, I would look to reorient it back to the zero. And if it's oriented to the right, I would again look to reorient it back in a similar way. So I implemented this using a P controller, wherein I tuned a value for KP to reorient the robot whenever it deviates from its path. This was the best performance I could get out of the robot. The vaccines were easily picked up by recognizing the QR codes, and it localized itself according to the indicators. And the robot was also able to deliver all the three vaccines to the injection area and return back to the cold storage area as well. The only problem though was I had to give it a tug at times for the in to pivot itself in the carpet flooring. But apart from that, this was a significantly much better performance than what I accomplished in the grand challenge.